Howdy, howdy. So we're going to talk about area of a triangle, and I'm going to give you some new tools that you probably have never used before to help you figure out the area of a triangle. We're going to use some trigonometry, and we're also going to use what's called Heron's, and some people call it Hero's formula. Which one is the correct one? I don't know. It's equally well known as Heron's and Hero's formula. So we think about well, how do we figure out an area of a triangle based on what I know? Well, probably the formula you've used is area equals 1/2 the base times the height, where this is like one side the base, and then the height is like an altitude drawn to that base is really what that is. Now, the only thing is that maybe you've realized sometimes it's a pain in the neck to figure out what the height is, especially if you only have like a couple of these sides. Like if I only knew this side was 11 and this side was 6, and I said figure out the area of the triangle, we might get a little bit stuck on trying to solve that out. So I'm going to give you guys some ideas here. So let's say that I do 1/2 base times height. So based on 1/2 base times height, if I think about, well, the height has to make a right angle with that opposite side. Maybe I can use some trigonometry to help me out here. So I know that, let's say I know that this angle and I know these two sides. And I'm trying to figure out how tall is this triangle. What is the height? So if I know how big that angle is, or essentially I have a side included angle and a side, well, I could tell you what that height is by taking the sine of angle C. The sine of angle C would be the opposite to the hypotenuse, so that would be h divided by a, and if I multiply both sides by that side a times sine of angle C is the height. So doing some substitution in here, another formula for the area for any triangle is 1/2 the base times the side A, which is the included side. So I have two included sides here, A and B, and they include to make angle C, and C is the included angle between those two sides, times the sine of C. So all I did was just replace this H with this. Or if I rewrite that so that way it's in like alphabetical order, 1/2 A times B times the sine of the included angle. So if you have two sides of the included angle, you can just take 1/2 the product of the two included sides times the sine of the included angle, and that's also an area for that triangle. So let's try this out. So here again, like 1/2 base times height. Oh, crumb. How am I going to figure out how tall that height is? It's a lot of work. Instead, since I have a side included angle and a side, I can use use some trigonometry to help me figure out the area. So the area of this triangle is 1/2 the two included sides times the sine of the angle. And you guys should know the sine of 45 degrees. Sine of 45 degrees is √2/2. Half of 48 is 24. 24 √2 divided by 2, that reduces to 12 √2. So there is the exact area of that triangle. Sweet! Moving right along here. So let's find the area of this triangle. Okay, so I moved the base, I moved the angle, it doesn't matter. The area is the two sides, the two included sides, half the product of those two included sides times the sine of that included angle. So the sine of 70 degrees. Now here I'm going to have to use my calculator, double check, make sure that it's in degree mode. So 1/2 times 6 times 9 times the sine of 70, because I don't know what the sine of 70 degrees is. It's not on my unit circle. So that would be 25.4-ish for the area. Whether this is in inches, and so this area would be square inches or something like that, I don't know. But 25.4 square units. So what if I don't have that? What if instead I don't have the angle, but instead I'm given three sides? Well, there's another formula called Hero's formula. If you want to know where it comes from, you can go ahead and Google it. But I'm not going to go through where it's coming from at this point. But I thought that the law of sine, the sine formula that we came up with right here, that was something that you guys could derive pretty easily. But Heron's is a little bit more extensive than that. So there's a formula, a different formula for the area of a triangle given three sides. So the S on here, well, A, B, and C, that's just representing the sides of the triangle. The S's is representing semi-perimeter. What do you think semi-perimeter means? Like, what does a semicircle means? It means it's half of a circle. So semi-perimeter is the perimeter cut in half. So if I have a triangle, okay, all these different sides, if I want to know what the semi-perimeter is, then add up all those sides together and cut it in half. So that's the semi-perimeter. So the area of a triangle, if you're given 3 sides, is that semi-perimeter times the difference between the semi-perimeter of each and every one of the sides, and take the product of all those, and there you have, and then square root that. Don't forget the square root part, and that is the area. So for example, here's a triangle, and the sides are 4, 5, and 7 apparently. Find the area of this triangle. So don't use a trigonometry here, because I don't know how big the angles are. I just have the sides are 4, 5, and 7. This is definitely not a right triangle here. I don't remember a 4, 5, 7 triple. So thus, figure out the semi-perimeter first. So add up all those sides together and cut that in half. 4 plus 5 is 9, plus another 7, 16. 16 cut in half. Semi-perimeter here is 8. So the area is the square root of that semi-perimeter times the semi-perimeter minus the first side, semi-perimeter minus the second side, semi-perimeter minus the third side. So the area is the square root of 8 times 4 times 3 times 1, which, let's see here. Well, I can break up the 8. I'm trying to get this into perfect squares. So 8 is 4 times 2. And then I also have this times 4 times 3 times 1. Now why did I do that? Well, because I know the square root of 4 is the number 2. I know the square root of this 4 is another number 2. So both those can get pulled out front. And inside the radical, I have left over a 2, a 3, and a 1. 2 times 3 times 1. Giving me 4 times the square root of 6. So there's the area of that triangle. So you can try real quick just to practice. Find the area of this triangle. Go ahead and give it a try. And if you've done it correctly, the answer should be 6 square root 26. Good luck. Boy, this was a super short video. This is April and Rainey, and I am signing off.